Okay, so this problem here, this will be the last problem of chapter 5. And what we're going to do is we're going to look at, there's 200 newtons going down. It says this is fixed. It's not a collar, by the way. It's welded to the rod or something. So this is a fixed support, but there's only 200 newtons acting downward on it. Ball and socket joint. No moments, 3 axes of force. And we'll call this AX, AY, and AZ. Let's see, force is here. Only collinear with the cables. F, BE, is that a good description of it? F, BD. Okay, are there any other forces acting on this thing? No, there isn't. And they call it TE. I will switch to TE. I will switch to TE and TD. Okay, TE and TD. Okay, so the forces of equilibrium, each component in all 3 directions has to sum to 0, which gives us these equations. Here's another look at the free body diagram. So TE plus AX has to sum to 0, AY plus TD has to sum to 0, and AZ minus 200 has to sum to 0. So that gives us a lot of those. Now, the trick is getting the moments around A. So this will take the cross product. I'm going to go over to MATLAB to do this. But first, we need to get the coordinates. So we know in the x direction, it's this point right here. 1 meter in the x, 2 meters in the y, and AB. We're looking for from here to here. So it starts at 0 in the coordinate xy. It starts at a positive 2 coordinate of the z and goes down to a negative 2, or 0, goes down to 0. So the vector would be 1, 2, negative 2. That'd be the vector direction. Now I'm going to go over to New Octave, the MATLAB lookalike, to finish up this problem. Okay, I set this system up as a matrix equation. So we go to our previous slide, and okay, there we go. So it's AX plus TE. So you have the matrix AX, AY, AZ, TD, TE, the 5 unknowns. It's a simultaneous equation solving that you do in linear algebra, the 5 unknowns. So this represents AX plus TE. AX plus TE equals 0. AY plus TD equals 0. AY plus TD equals 0. And then finally, AZ equals 200. That's what this is saying. AZ equals 200. Then twice TD equals 200. Now, to figure that one out, you find the moment about A, and you get RC, that's half the distance, plus RB cross TE plus TD, these two vectors. This vector crossed into this vector to get the moment about A. This vector crossed into this vector to get the moment about, add to the moment about A. None of these forces will contribute to the moment. We're taking the moment about A because we eliminate three variables right off the bat. So when we expand that out, RC is half of RB. RB is 1, 2, negative 2. Let's go to the previous diagram. So this vector down here, 1 meter in the x, 2 meters in the y, negative 2 meters in the z. So half of that, 1/2, 1, negative 1, I hat, j hat, k hat. I don't know what that flash was. It popped up another program on my computer. Anyway, we're back here. Acting on, and the force that creates that moment is the 200 newtons going down. So I hat crossed into k hat gives you a negative j hat. So 0.5 times negative 200 times negative j hat, right there. J cross k is going to give you a negative I. Is that correct? No. Positive I. Positive I. J, K will give you a positive I, so that's negative 200 I hat. And then K hat cross K hat 0. So now we're over here. I hat cross I hat 0. I hat cross J hat is K hat. So you have TD, just plain TD K hat right here. 2J hat cross I hat is going to give you negative K hat. So it's negative 2 TE K hat. Negative 2 TE K hat. And then J cross J is 0. Negative 2 K hat, K cross I is going to give you a positive J. So negative 2 TE J hat. Negative 2 TE J hat. And then K cross J is going to be a negative I. Negative 2 times negative I is 2 I hat times TD, okay, equals 0. And just looking at individual terms, we can say, okay, let's just look at the I hat terms. Negative 200 becomes 200 positive on the other side of the equation. And where's the other I hat term? There at the very end, 2TD. So 2TD. Okay. Now, then we have a negative 100 on the right-hand side of the equation. I'm looking for the other j hat term. Negative 2TE. So there's that, negative 2TE. So that's how you set up a matrix equation. This doesn't really need matrices to solve, but this illustrates how to set these equations up to solve them using matrices. So let's go to new octave. Okay, there it is. So I set up the matrix that I just showed you. 1 0 0 0 1 0 1 0 1 0 0 0 1 0 0 0 0 0 2 0 0 0 0 0 negative 2. 1 0 0 0 1 0 2 0 1 0. Oh, wrong. I corrected it. 0 1 0 1 0. Had to fix that. So, enter your matrices properly. And then times the unknown vector of unknowns, is going to equal the outputs of each equation. And here's the outputs: 0, 0, 200, 200, negative 100. 0, 0, 200, 200, negative 100. Okay, and then you get the solution. So AX, negative 50, AY, negative 100, AZ 200, TD 100, TE 50. Let's go back here. TD 100, TE 50. Same as the book. AX, AY, AZ, negative 50, negative 100, 200. Negative 50, negative 100, 200. Okay, so that finishes this problem. How to set it up, and then, of course, how to do number crunching. And end of our discussions, end of this chapter.